Hello everyone, welcome back to another video. Let's look at the vectors and Newton's laws questions from this paper. Question 1.1, which one of the following pairs of physical quantities consists of a vector and a scalar? I've done questions like this before. You can remember all your vectors using DAM, VW, FM. D is displacement. A is acceleration, M is momentum, V is velocity, W is weight, F is force, and M is magnetic field, or any field for that instance. So given that, let's look at our options: A, force, and distance. Okay, we know force is a vector, distance is a scalar, so the answer is A. Question 1.2, which one of the following diagrams is the best representation of the vector sum x plus y equals minus z? Now, you look at this question immediately, happened to me, and you'll think, oh gosh, what is this? So really all you got to do here is you got to take the minus z across. So you have x plus y equals minus z. Take that across, and then you got something more familiar. X plus y plus z equals 0. So what this means is you need to look for a closed triangle. We're specifically looking for a head to tail. Head to tail. The whole triangle should be head to tail. And that option corresponds with C. Okay, question 1.3. A crate of mass M is pushed across a horizontal surface by force F, acting at an angle. The crate experiences a constant friction. How will the magnitude of the friction be affected if F is increased? Okay. So let's look at the equation for F first. So friction is equal to mu k times Fn. So we need to figure out what effect does increasing the force applied have on Fn. So we know that this force is acting at an incline, right? So we're going to have components. We're going to have a vertical component and a horizontal component. Okay? Now, the vertical component, that's equal to F sine theta, right? And if we look at a free body diagram for the forces acting on this, and we just focus on the up and down, we're going to get Fn here. We're also going to get the vertical component, and we are going to get Fg. Now from here, we can make the conclusion that since this object is not moving up or down, it means that the forces in the vertical direction are equal to each other. So in other words, we can say that Fn is equal to Fg plus Fy. Okay, so we've got our equation set up. Now let's look at what happens. If I increase F here, that means Fy is going to increase, right? You can check it mathematically, but that's basically what's going to happen. So Fy is going to increase. Now, if Fy increases, that means Fn will increase. And if Fn increases, now we're back at our original equation. If Fn increases, it means that the friction will increase. So the answer to 1.3 is B. All right? Let's move on. Question 1.4. The diagram below shows a book which is pressed against a wall by a horizontal force F. Which one of the following represents an action-reaction force pair according to Newton's third law? So let's look at the options here. We have option A, the weight of the book, and the force F on the book. Okay, so the weight of the book is acting downward. So that's Fg. That's the weight of the book. So they're not action-reaction pairs. They're not in the same direction. They're not the same magnitude. So that's not going to be our answer. B, force F on the book and the force of the book on the wall the force of the book on the wall is this way. So that's not going to be the option either. Let's look at C. The weight of the book and the force that the book exerts on the earth. Now that might sound like an option, but let's look at the last one. And then we can make some conclusions here. D. The weight of the book, we've drawn it in here, and the friction between the book and the wall. So if we carefully consider this, the frictional force is actually pointing upward, right? Because this book wants to go down, right? Gravity wants to pull the book down, but friction is actually holding the book up. So actually, this would be static friction because it's stationary, right? They are equal to each other. They're acting simultaneously on this object. And so the answer here is going to be D. Okay, let's move on. Question 1.5. A satellite experiences a gravitational force of magnitude F on the surface of Earth. Okay, the radius of the Earth is R. The satellite now orbits the Earth at an unknown height above the surface of the Earth and experiences a gravitational force of magnitude 1 over 6F. This unknown height above the surface of the Earth is what? Okay, so let's maybe we can draw a sketch out here and see what's happening. So when it was R and the satellite, let's draw the satellite like this. The distance was R, then there was a magnitude of F. So F equals G M1 M2 over R squared. In this case, it's capital R squared. And so the answer was F. Now, it is some distance above. Let's say it's there. And they want to know, what is the height above the surface? So they tell us now that the force is 1 over 16. Right? They tell us the force is 1 over 16. So how we can do this, we can say F equals G M1 M2 over R squared. Right? Now, since the objects are staying the same, the Earth is the same, the satellite is the same, the change in this force had to have come from the change in the height. Okay? Now, since this height, or since the distance is squared, what we need to do is we need to square root that. So we'll say the square root of 1 over 16 is 1 over 4. Right? So in other words, the height or the distance from center to center is 4r. Right? I mean, we can obviously check this. We can say F equals G M1 M2 over 4r all squared. Then you'll get G M1 M2 over 16r squared. You can take the 16 to the front. You'll get 1 over 16f. So yes, we know we confirmed that it's 4r. But be careful. They want to know the distance above the surface of the Earth. 4r is from center to center. So if the distance of the Earth, if the radius of the Earth is r, that means from the surface to this object must be 3r. So the answer there is C. Okay, let's move on. Question number 2. Three forces A, B, and C of magnitude 240 newtons, 350 newtons, and 200 newtons respectively act on point O. All right, define resultant. I mean, resultant, you have your definitions. Let's not waste time there. Calculate the magnitude of the resultant force. All right. So what we'll do is we need to break this up into components, right? So let's look at this force B. B will have a horizontal force. So let's call it X. Let's call it BX. So the X component. And then this will be BY. All right. Then let's look at C. If that angle is 50, this angle here must be 40. This is going to be CX. that's going to be Cy. And then A has no components. It's acting in a straight line. All right. So let's do our components. So we will say 2.1.2. Let's look at B. So for B, we'll work out the x component. We'll say Bx equals, it's going to be 350 times cos 70 degrees, right? So 350 times cos of 70, that's equal to 119,71. So 119,71 newtons. Then we'll do By. By will be 350 times sine of 70 degrees. And we'll get an answer of 328,89 newtons. Right? Let's just put in the directions here so we have track of it. This is pointing to the right. That's going to point up. Okay? Let's do C. So Cx is going to equal 200 times cos of 40 degrees. So let's just get this. 200 times cos of 40. That's 153,21, and that's going to the left. Cy is 200 times sine of 40 degrees. (128,56), and that's pointing down. And then for A is simply 240 to the left. So if we want the resultant here, all we have to do is we need to add up the forces. So we will say that the resultant in the x direction, that's going to be 119,71 minus 153,21, and then minus 240. So you put that in our calculator. 119,71 minus 153,21 minus 240. That's minus 273,5, and that's basically 273,5 to the left. Right? Now let's do the resultant in the y direction. So the resultant in the y direction is simply going to be 328,89 minus 128,56, and that would give us 200,34, and that's pointing up. So if we want the resultant now, so we got the components of the resultant, we want the actual resultant, we need to convert this into a triangle. Okay, so convert this into a triangle. We have a force going here, that's 273,5. Then we have a force going up that way, which is 200,34. Our resultant is actually going to be this one, right? That's our FR, and it's going to be the hypotenuse. So you work out the hypotenuse, and we will say that the hypotenuse is equal to, so we'll say FR squared is equal to 273,5 squared plus 200,34 squared. Then you will square root, and then you will get an answer of 339,02 newtons. They ask for only the magnitude, so we don't need to work out direction, work out theta, and so on. All right, so key thing here, break it up into components and then add the horizontal and then add the vertical and then do your triangle. Okay, next question, question 2.2. The apparatus below used to determine the resultant of two coplanar forces F1 and F2. Calculate the magnitude of F1. So F1, So this force, this is tension, right? So tension is acting that way, and it's going to act this way right here. Okay, it acts away from the point. So if I have to draw in just a quick free body diagram for this, you're going to have tension pointing up, and you're going to have Fg pointing down. Since it's all stationary, Fg is going to equal tension. So we can work out the tension by saying, so 2.2.1, we can say that tension, or F1, let's call it F1, is equal to mg, which is equal to 77 over 1,000 multiplied by 9,8, and that is 0,775 newtons. 2.2.2, a mirror is used to plot the images on the forces acting in the string, give a reason why the mirror is used. So it's used for accuracy. It's more accurate, and it avoids something called the error of parallax. Okay, I think parallax is 1R. So for accuracy and to avoid the error of parallax. 2.2.3, an incomplete diagram for the results of this investigation is given on page 15 of this question paper. Complete the diagram using a scale. Okay, so obviously I can't use a scale, I can't use the same thing, but we'll do more or less an estimate. So on the page you have a force going down. You have like a line like this, you have a line like this, and then you have a line like this. So that basically is representing this region here. Okay, so you know what F1 is. You can work out what F2 is, and then by doing so you can work out what the F net is. Okay, so what we got to do now is, we know F1, we worked at F1 is 0,775. So you use your scale, right? You use your scale and you will draw this line in, right? If the scale was, I think the scale, what's the scale? 10 millimeters. So 10 millimeters equals 0,1 Newton. So if you want 0,775, you want to know how many millimeters that needs to be. All you need to do is you cross multiply. So 0,1 n equals, this is 7,75. Then you'll say, then you divide, right? Don't worry about that. That's times x. And then you'll say x equals 7,75 divided by 0,1. That this should be 77,5 millimeters. So this length should be 77,5 millimeters. Okay, and once you do that, you will repeat for F2. Now for F2, they've given us the same, it's actually the same mass. So the force will be the same as well. So this will also be 77,5 millimeters. Now, from here, what you need to do is you need to complete this quadrilateral. And what that means is you need to draw a parallel line to F1 and a parallel line to F2. So for F2, the line would look something like this. And then for F1, the line would look something like this. And the resultant is actually going to be the line that's drawn from this point there. So you measure it, you'll get the length in millimeters, and then you then convert it. Okay? And once you do that, you'll get that the force, so the F net here, let's call it F net. The F net is actually going to be 0,70 newtons. So again, main thing here, once you draw in that blue line, once you draw in that F net, you have to measure it. And then use the same method here, use the scale, and then convert it to newtons. Okay. 2.2.4, hence calculate the mass of X. So 2.2.4, what we've basically done in the previous question is we've replaced these two forces with this one blue force. So we have the force pulling down, which is Fg, and then we have the resultant of those two forces, F1 and F2, F net there. Now, since this object is not moving, right, this F net is this, we can say that Fg is equal to 0.70 newtons. And Fg is equal to the mass, which is x, times gravity, and at 0.7, that means x is equal to 0.7 divided by 0.7 divided by 9.8, and you get an answer of 0.07 kilograms. More or less. Again, it depends. There may be slight differences. They will allow or account for that, maybe a few millimeters, which will cause the force to be different, but that's the basic idea. Again, it depends on your actual drawing. Your actual drawing may be a few millimeters off, and so your F net will be slightly different. And if your F net is slightly different, that means your mass is going to be slightly different. But they will account for that, so you don't need to worry about getting the exact same answer. Okay, let's move on now. So we are on question number 3, question 3.1. The experiment below was used to verify a relationship between the acceleration produced and the net force acting on an object. Learners set up the apparatus as shown below. So the results obtained are used to plot the incomplete graph, write down the name of the quantity that must be kept constant in this experiment. So you would have done this experiment in class, and the quantity you need to keep the same is the mass. Right? You need to keep the mass the same. All right? Moving on. On the diagram sheet provided, draw the graph that can be expected. So the diagram sheet looks basically like this, right? It's basically the same graph. And what they want you to do here is they want you to draw in the line of best fit. Now, the line of best fit is that line that joins through most of the lines, if not all. So the line of best fit we can draw, it looks something like this. So it goes through most of the lines, most of the points, not all of them. All right? And you would have done something like this in class. So that one's done. 3.1.3, state in words the mathematical relationship between acceleration and the net force. So here you can see that as the net force is increasing, the acceleration is also increasing. So that type of relationship is called directly proportional. Directly proportional. So that means as one increases, the other also increases. Use the graph to determine the acceleration of the trolley when the net force is 0.25. So here you're reading off the graph. If the net force is 0.25, you extrapolate up to that point and then bring it across, and you'll get an acceleration of 0.5 meters per second squared. So that one, 0.5 meters per second squared. And then the last question, calculate the mass of the trolley. All right. Now, since this is a straight line, we can calculate something called the gradient. Okay, let's figure out what the gradient gives us. So to calculate the gradient is equal to the change in y divided by the change in x. On my y-axis, I have acceleration. So that's going to be a divided by f net. Now let's look at our equation for Newton's second law. F net equals ma. So if I take a across, I'm going to get F net divided by A, that's equal to M. Now, if I look at this and this, the fraction is the other way around. We want A over F net. We don't want F net over A. So what we need to do is we need to invert this. And if I invert it, I need to invert this. So that's going to be 1 over M. So in other words, if I work out the gradient gives me 1 over M. So let's work out the gradient. We need 2 points. We have 1 point here, 0, 0. And let's take another point. Let's take the last point. So 0, 7 and then 0, 35. So let's take this last point. Okay. Any 2 points would work. The easiest 2 often is sufficient. So the change in y, so it's going to be 0, 7 minus 0 divided by 0, 35 minus 0. And that's equal to 1 over m. Remember, the gradient is equal to 1 over m. So now we can solve for m. We get m equals 0, 5 kilograms. You could also use F net equal ma. I mean, if you didn't want to do the gradient route, you could say F net equals ma. You know the F net was 0, 35. That's equal to m times 0, 7. And if you solve for m, you're going to get 0, 5 kilograms. That also works, but it's good to know both. Okay, question 3.2. 2 crates of mass 25 kilograms and 50 kilograms are connected by a light inextensible rope. A force of 200 newtons is applied to the right as shown in the diagram below. The crate moves with an acceleration of 1.25 meters per second squared to the right across a rough surface. The coefficient is the same for both crates. Okay. State Newton's second law, that's a definition. You have access to that. Question 3.2.2, draw a labeled free body diagram showing all the forces acting on the 25 kilogram crate. So the 25, this crate here. So there's going to be a force applied. There's going to be the normal. There's also going to be gravity. There's going to be tension. And it's a rough surface, so there's going to be friction. And 5 marks, they're basically looking for 5 forces. So this is 3.2.2. 3.2.3, using relevant calculations, show that the coefficient of kinetic friction for the crates and the surface is 0,144. Here, we've done questions like this before. 6-mark question usually involves simultaneous. If not simultaneous, it's often going to involve multiple calculations. So this is for the 25 kilogram. What we will need is, we'll also need one for the 50 kilogram. 3.2.3, we'll draw a free body diagram for the 50 kilogram block. For this block, you're going to get a tension force, a normal force, a force of gravity, and then a friction. Now, we'll apply F net equal ma to both. We'll say F net equal ma. Then for this one, it's going to be the force applied minus the tension minus friction equals ma. Let's substitute. So 200 minus T minus. Now, just for a second, let's consider the friction. Will the friction for the 50 kilogram block be the same as the friction for the 25 kilogram block? Remember, friction is equal to mu k times Fn, right? And for both of these blocks, Fn is equal to Fg. And Fg is dependent on the mass. So for the 25 kilogram block, since it is half the mass of the 50 kilogram block, the kinetic friction is going to be half. So for the 25 kilogram block, we're going to put half F. And that's going to equal 25 times 1,25. And for the 50 kilogram block, we'll apply the same thing. F net equal ma. T minus F equals 50 times 1,25. Now it's clear that there's 2 unknowns, and so we'll need to do simultaneous equations. Let's solve in terms of T.
you're going to get T equals 50 times 1,25 plus F. Now we can substitute this into the equation on the right hand side. You'll get 200 minus, open bracket, we have 50, 1,25, and then plus F, and then here minus half F equals 25 and 1,25. So here you can simplify, and once you simplify, you solve for F. You're going to get F equals 70,833 newtons. But remember, they wanted us to calculate the coefficient. So remember, Fk equals mu k times Fn. So we know 70,833 is equal to mu k, and then Fn, as we said earlier, for the 50 kilogram block, Fn is equal to Fg. So in place of this, we can just say 50 times 9,8. And you solve for mu k. Mu k is 0,144. And we've solved it. Last question, calculate the magnitude of the tension in the rope. So if you got the friction, we can just use this simple equation here and then solve for the tension. So we have friction, we can solve for tension. So let's use a different color. So we can say that tension is equal to 50, then 1,25 plus 70,833. And the tension force is then equal to 133,33 newtons. Let's number this, 3.2.4, and done. Okay, let's move on. Question 3.3. A block of mass M1 and a ball of mass M2 are connected by a light inextensible string passes over a frictionless pulley as shown below. It's placed on a rough horizontal surface. Okay. How will the acceleration be affected if the mass M2 is doubled? So if the mass M2 is doubled, then if you want, you can draw a free body diagram. Fg, Ft. If we double this mass, then the object or the system is going to accelerate more. It's going to increase. The acceleration of the system is going to increase. Right? The whole system is going to move down because of that mass has increased. So it's going to increase. So for 1 mark, I don't think they need any explanations. Let's move on. Question 3.3.2. The mass of the block M1 is doubled. And now for 4 marks, I want you to fully explain. Okay, so let's look at what will happen first. So M1, right, there's tension there, there's friction there is a normal there, and then there's gravity here. If you double the mass, right, so if Fg is doubled, that means since the system is not moving up or down, it means that Fn is going to increase as well. Right? It's actually going to double. Right? And if Fn doubles, then that's going to have an effect on friction. Because remember, friction is equal to mu k times Fn. And if Fn increases, it means that the friction is going to increase. And since we can see here that F net equals ma, T minus the friction is equal to ma. If the friction is increasing, it means that the acceleration will get smaller. So the whole system, the acceleration of the system will decrease. Okay, question 3.4. A block of mass 5.8 kilograms is pulled up an incline at constant velocity by a force F that makes an angle of 25 degrees with the horizontal. The kinetic friction force between the block and the surface is 51,51 newtons. Calculate the magnitude of force F. So they tell us constant velocity, And so what that means is F net is equal to 0. Okay, let's draw a free body diagram. There's going to be a force applied. There's going to be a normal force. Then there's gravity. But this gravity has components. It has a parallel component, and it also has a perpendicular component. Now, we are interested in the parallel component. The parallel component is equal to mg sine theta. Right? So what we can do now is we can choose a direction as positive. Let's choose up as positive. That means the force applied minus, and there's also friction, sorry, minus friction minus Fg parallel is equal to 0. So next we can say that the force is equal to friction plus Fg parallel. The force is equal to friction, which was 51,51, plus mg, so 5,8 times 9,8 times sine of 25 degrees. That means the force is then equal to 75,53 newtons. 3.4.2, the applied force is now removed. Briefly explain the motion of the block immediately after it's removed. So 3.4.2, once this force is removed, right, the object will continue up. And this is because of inertia. Then it will stop. Okay? So it will continue up because of inertia, and then it will come to a stop. Let's move on to the last question, question 4. State Newton's law of universal gravitation. This is given to you. You have definitions, so you don't need to worry about it. You do have to worry about it. You have access to it. Question 4.2. A communication satellite of mass 1,500 kilograms move in a fixed orbit around Earth. Earth exerts a force of magnitude 10,500 newtons on the satellite in order to keep it in the specific orbit. Calculate the distance in kilometers of the satellite above the surface of the Earth. Okay, so we know F, that was given to us 10,500. We've been given we know G is 6.67 times 10 to the minus 11. We know the mass of the Earth. The mass of the Earth is 6 times 10 to the power 24. We know the mass of the satellite is 1,500. And we can work out R. So we'll say that F equals G m1 m2 over R squared. 10,500 is equal to 6,67 times 10 to the minus 11. M1 is 6 times 10 to the power 24. Then 1,500, and then divided by R squared. And then you solve for R. R is equal to 7,56 times 10 to the power 6 meters. But remember, let's just make this clear. You have the Earth, you have the satellite. What we worked out is we worked out the distance from center to center. That's 7,56 times 10 to the 6. They want to know what is the distance from the surface of the Earth. So we need to remove the radius of the Earth. So we'll say this minus the radius of the Earth is given to us, 6,38 times 10 to the power 6. And you get an answer of 1,18 times 10 to the power 6 meters. If you want it in kilometers, then divide by 1,000. Dividing by 1,000 just means reducing that exponent by 3. So that's going to be 1,18 times 10 to the power 3 kilometers. And that's it. If you like this video, please give it a thumbs up. If there's something specific you would like me to do, please let me know in the comment section below.